Cool. Ready when y'all are.
Okay. Do you want us to just get started or
Yeah, go for it.
all right. Hello everyone. I'm Ian. Uh
What's up? I'm Nikhil.
so we're gonna be teaching the Intro to Git workshop. It's meant for beginners, and but even if you know how to use Git, hopefully you'll learn a few tricks. Let me share my screen. So yeah, we're gonna be teaching Intro to Git.
Yeah, so I can start with the first slide. So you probably have some rough idea of what Git is coming into the presentation, but we just decided to formalize it as well. So Git itself is a very useful version control system, meaning that you can work on and work with multiple versions of code that you're working on in your project. So more generically, it allows a lot of people to work on many different versions of the project at once and different parts of the project as well. Git is directly integrated into your command line, and there's also software for it, like visual software for it. So you can maintain different versions of the code and work with different versions of the code using terminal, or you could use other software for it that we can go over later. And Git is mostly used with GitHub. You've almost definitely heard of GitHub, where you can create repositories and store code. Git, the system, the version control system, is used in conjunction mostly with GitHub. And both of these combined essentially double up as Google Drive for code, but it's a lot more interactive. It's a lot more interactive, and you can definitely work with multiple versions and different features of a project with Git.
Right. So why use Git and GitHub? It's a form of version control and allows multiple people to work on a different code base or the same code base at once, but with different versions. And you can do this and achieve this by using multiple branches, which we'll talk about at a later time. And it's an easy way to back up code from your computer. So you can store code on GitHub in case anything happens to your local machine. There's a copy on GitHub that is up to date. And by doing this, you're also showing off and you're also able to find other people's cool projects on GitHub. And a good way to learn computer science and coding is to contribute to various open source projects, which are projects where pretty much anyone can contribute. And they're usually really well organized, and they're really large projects. And I think companies really like it if they see that you're contributing on GitHub frequently, because it means you're working on code a lot, and the companies like to see that.
Yeah, so before we move on, I just wanted to say really quickly, if there's any questions at all, by the way, you can drop them in the chat or just unmute yourself and ask them. Or you can save the questions till the end. That we have a specific set time for Q&A as well. But if there's anything urgent or something that you might think you forget, you think you might forget, you can put it in the chat and I'll be checking, and Ian will be checking too, and we can answer questions there as well. So just wanted to bring that up. So now back to the presentation. So to get started, you have to go to github.com, and you can create an account if you haven't, or if you have, you go to your account and you can create a new repository from the repositories tab, or from a local terminal. You can use the command git init, and this will create a repository for you on an existing local project, so code that you're working on your computer. You can also the other method, clicking on repositories and then clicking on new. That's what you can do from the browser itself. So once again, two different ways to do the same action. Depends on whether you're more comfortable with the browser or terminal. You may be more comfortable with the browser to start with, but we highly suggest you get familiar with the terminal. It'll be very it'll come in, it'll be super useful later on when you need to work with a lot more complex code. And you'll just be thankful that you have Git mastered on the terminal. So definitely spend some time doing that. You can either choose repositories to be public or private, and repositories should generally be private unless you can make sure that your code has no security issues and that you can share it publicly. And if you are a student, you can get free private repositories. So that's really useful. So make sure you use your student email when you're signing up for GitHub.
It's been a while since I signed up for or like renewed my student account, but I think all you have to do is either you have to send your student email or show your student ID, like take a picture of it.
Yeah.
It's a really easy process.
Yeah.
And
They
I
ask for
can
like verification, I think, but it's not that hard. Like you just follow their steps. Oh yeah.
yeah, and I can share my screen to do a little do a little demo, and please feel free to follow along. So first you're gonna go on github.com, make an account, and then you'll click this green button here called new, and it'll take you to create a new repository. This is the owner, which is me, and then the repository name, which for this sake of this tutorial is going to be tutorial. No description, although you can do anything. Oh, interesting. I didn't know that GitHub made unlimited private repos. Okay. Um, it's been a while. So any description, and then you can choose to make it public or private. And for the sake of this tutorial, I'll make it private. And you can choose to do any of these. They're all pretty crucial things, but for this tutorial, you won't need any of them. And then click create repository. And there's going to be a bunch of complicated stuff, but essentially all you need to do is, let's see, yeah. So you can first, on your local machine, clone the repository you just created. And that's going to be this link, git clone, and then the link of the git clone, and then the link of the actual repository itself. And now clone the repository onto your local machine. So it says this little link right here, or if you just go to the main page, this page right here, you just copy this and paste this into your terminal, which I'm not sure if I'm not sharing. Maybe I should just share my desktop and not my.
That might be easier.
Can everyone see?
Yeah, we can
Yeah,
see
we
this.
can
See
see
my
it.
terminal. Okay. Yeah. So you go to your just go to any folder that you want to go to where you want to create the new repository. You do git clone and then the link, and then yeah. So warning, you pretty have cloned an empty repository, and that's an okay error because the repository is originally empty. And then or you can also do git init to initialize a local repository. There's different steps that that are required to push to a remote repository that are a little more complicated, as you can see. But yeah.
Yeah, the nice thing is that if you can go back to that other screen, Ian, really quickly, or not on the slide, the GitHub screen, the web page. Yeah, so you can see that like they give you a lot of the code you can start with initially. So that's really nice. So definitely take like, if you look at the top, it'll tell you how to create a new repository using the command line. And like if you look at the specific lines themselves, they're all mostly self-explanatory, but most of these commands, like all these commands are basically what you'll be working with whenever you use GitHub. So it's definitely like use these code snippets if you need when you initially create your repository. But in general, so if we can go back to the presentation. Here's a couple of commands you can use to work with files in GitHub. So before we start, so the title of the slide is pushing your changes to the remote repo. And so what a remote repo, it stands for remote repository. And whenever you're thinking of or like working with a repository in GitHub, you're gonna always actually, let me see. Seems to be a question. Well, yeah, I think so. This is being recorded and it's being live streamed on YouTube. I think it's accessible in both those places. So yeah, it should be accessible after. And so there's a concept of a local repository and a remote repository, and the local repository is just the version of code that you have saved on your computer, and the remote repository is the version of code or the version of code that GitHub maintains for you. So that's what pushing your changes to the remote repository stands for. It just means whatever changes you've made locally, you're making sure that the GitHub server now has those. And so there's a couple of commands you can use that are super helpful. The first one is git status. If you run this in the terminal, it'll give you basically an overview of every like file that you've modified and like what stage is it in and like where is it exactly, etc. It's very, very useful. I use git status a lot to make sure that my commits and everything are going to be good. And so basically, so git status, yeah, it allows you to check all the changes you've made to every file, and it allows you to check the status of the different files and the status of the commit. And a commit is just simply, the commit is also very self-explanatory. A commit is just one iteration, one push of the files. So basically, let's say you've maybe fixed some bug that you saw in the code. Every file you've changed to fix this bug, every change you've made in general, you'll usually group all these together and push it to the remote repository, like store the code on the remote repository in something called a commit. So that's what a commit is referring to. And you can check like the status of this commit, how much have you built, how much do you need to still add files to it, etc. Using git status. You can also use git pull origin branch name. So we'll talk about branches once again in a bit, but it makes sure that any code that you've had on GitHub is up to date with what you have locally. So, it'll make sure that your local code is up to date with what's there in the remote repository. So you always want to do this git pull origin, and then specify a branch name. So it says default master. I think the GitHub branch repositories are say main now. So I think it might be the main branch, but so you might want to do git pull origin main, but so what that does basically is just take all the code that's available in the remote repository and store it on your computer. And you absolutely need to do this before you start working on any code. Because if you do it after, it's going to overwrite any code you have locally unless you make sure to do it carefully. And if it can accidentally overwrite your changes. So you have to be very careful to do it before you start working on any local code, but you need to make sure to do it. Otherwise you cannot push your code to the remote repository because they'll be out of sync. So make sure you do this, every once in a while, and make sure you save your progress locally as well. Yeah, so the next command is git add, and you can see that there's different variations of it. You can either do git add and then dot to refer to every file in the current folder and scope, or you can do git add file name to just add a specific file, and git add just simply adds that file to the commit. So it includes the file as part of the code that's going to be pushed to the remote repository and change the remote repository. And then you're doing git commit -m my message. So it simply just takes all the files you've previously added using git add and stores it into a commit with a certain message that you're supposed to put a couple words describing what that commit is doing. So for example, like I said, it could be a bug fix, it could be adding a new feature, etc. And finally, when you do git push origin branch name, it'll push your changes and whatever you've committed so far onto the remote repository, and it can push it onto a specific branch. But if you don't specify anything there, same as above, it'll default to main. And that will cover most of the commands that you need to know in order to take a couple of changes that you made locally and push it to the remote repository.
Yeah, so I can do also a short little demo. So you can go into your Git repo, create a new file. Just example that text. So you can just go, hello, hi, hello, and then save the file. And now there's a file called example.txt. And if you do git add, I'm not going to do pull because I know for sure that I'm the only person on this Git repository. And so the remote repository has for sure not been altered since the last time I accessed it. But if you're working in an environment where there are multiple people adding and pushing to the same remote repository, you should really use git pull. And I think Git will actually just prompt you to do it before you do anything else anyway. So you do git add and then the dot, which specifies every file at this scope or at this level of the subdirectory is going to be added to the next commit. So you do git add and then the dot, call git commit the message, and then
Wait, Ian, before you do that, can you git status real quick? Just to
Sure.
show how the files look before you commit them.
Yeah, so when you do git status, you can see that the changes to be committed are going to be there's a new file called example.txt. And to answer your question, Melissa, a push is you're pushing your version of the new commit into the remote repository. So whatever changes you made and added to a certain commit, you're changing the remote repository with that commit. Git pull is changing your local version to be up to date with the remote repository. So let's say you haven't pulled in a while, and it was a busy day at work, and a ton of people have changed. So push is like uploading to Google Drive. Correct. And in this case, we're pretending that Google Drive doesn't already automatically keep things up to date, and it requires you to manually upload and download from whatever documents or folders it has. If that answers your question. Thanks, Ansh. So where was I? So yes, I did git add and then git status, and then you can do git commit to create a new commit with message added. Example.
Real quick, just before you add, if you look at the git status, you can see that it tells you what branch you're on. It tells you how many commits you've made already, and it tells you what files have been changed that you haven't committed yet. So that's why git status can be super useful. It even tells you like what command you need to use to remove the file like from the repository, etc. So like make sure you look at all the information on git status. You can accidentally find yourself on a wrong branch, or like maybe you've already committed 3 or 4 things and you want to push at this point. So like definitely make sure you're always like looking at what git status does.
Yeah, I should honestly use git status more often. That's
I use it
really
I just like use it all the time, so I'm a big fan.
And then okay, so we've done git commit, and now the final action that solidifies or essentially remote updates the remote repository or the actual web repository that you saw on the GitHub website is you do git push and an origin master or main I guess in this instance. And default is going to be set to git push of the main branch anyway, but I think it's good practice to specify your branch anyway, because you might accidentally git push working or even a completely broken version of the code into a branch that you probably shouldn't, or which is the main product. Oh. Is this still master? Okay, I'm so confused sometimes.
Okay, maybe it is master. Sorry, I thought they updated that. Okay, that's weird.
Yeah, me too. I'm not sure, to be honest, but we'll move things along. So kind of as a recap, yeah, I thought they updated that too, because what's funny is last workshop I tried to do git push origin master and they said I had to use main, and now when I'm trying to use main, they're making me use master. So for a quick little recap, these are some really useful commands for updating and using GitHub. The first is going to be git clone, which, as you saw before, copies a repo from the initial GitHub repository on the on the website itself. So suppose you have to find a cool little project on GitHub that you want to work on. You git clone if you git clone and then you paste the link, that'll create a local version on your computer that is completely separate from the remote repository, as long as you don't add any changes to it. Git init creates a local repo from the command line based on an already existing folder. So suppose you have a folder and you forgot to and you want to add it to GitHub, you use git init. And then you have git status, which allows you, it's a really useful trick to review all changes made and the status of a commit. And you should do this before you commit anything to the remote repository. And we've been saying local and remote a lot, and hopefully that makes sense. But just as a quick little recap, local repo is the version on your computer, and the remote repo is the version on the GitHub website and on the server. So git pull, you pull changes made to the remote repo. So suppose if anyone else added changes to the remote repository, then you doing git pull will pull all changes to update your version to be the same as the one on the remote repository. Git add and then dot or the file name will add those files to the next commit that you make, where the command is git commit, the message, and then the message string or the message, I guess, description, which will create a new commit based on all the files that you choose to add. And then finally git push, which allows you to push the changes and the commit to your desired branch. And the default is origin master or origin main. I still have no idea. And you can specify the branch, which we'll talk about very soon. And then I think git log, which allows you to view the commit history and where the head is locally and the remote repository.
When we refer to head, by the way, it's talking about there's a variable, or not a variable, but there's something called the head, which points to the last commit made. So that you have two different like heads. There, one is like for your local repository, and one is for the remote repository. Because obviously your code can be different locally and remote, right? So yeah, if you take a look at the screen, like he did git log, which shows you all the commits made so far. Each one is associated with an ID, and it tells you where the head is, like locally, which is the green master, and remotely, which is the origin master. And you can see right now they're both one and the same, because I mean, Ian is the only one pushing code. So he's the only one that, he's the only one that has any repositories or like any commits that are going to be represented. So the head is going to match, but it is very possible that if you're working on a project with other people, the head for your repository will be at a different position than it will be for the origin. So always git log is a very useful command to just make sure that everything is good. And you can see that, sorry, go back, if you can go back to the terminal, you can see that his message that he added with the git commit, you can see it at the bottom of that git log output as well. So yeah, like make sure you can notice the small things like that you're adding with the commands. Yeah, I think git log is super useful to make sure that your code is up to date. So you can use it for that and make sure
Yeah,
that.
and also this is a little side note, but this is kind of a very unspoken rule. It's okay to look things up. There's going to be a ton of times where Git throws an issue where you don't know what's going on. There's going to be an error code or some weird bug, and nobody is that perfect where they just know every single trick and fix to fix any single issue. And Git has a very extensive user base, obviously, because most software engineers are using GitHub. So just look it up if you don't know how to do it. It sounds very kind of like it sounds like a very cheap way to back out of answering or knowing how to do certain things, but in like commonplace, most cases, if you don't know how to do something, there's going to be someone who knows how to do it, and it's going to be online. So
it's not worth your time either to like spend the time reading the documentation. Just like Stack Overflow will be your best friend for Git questions. And yeah, so I can talk about branches real quick. So branches, as their name suggests, allow you to start working on different parts of the code or keep different versions of the code based on what you want to do. So branches almost like a lot of the times, especially in the academic setting and like even in corporate settings, branches are used to implement different features and different functionalities of projects. So obviously something like a different feature is going to most likely mean that you're going to modify different like code, and you're going to have completely different like development iterations and etc. So branches allow you to keep the like code updates separate. You can work on code without breaking it for the entire like company or wherever you're working on it. So branches are super useful. And in order to create one, you use the command git checkout, but then you do -b, and then you put the branch name to create this new branch. And so if you remove the -b and you just do git checkout, and then you put the name there, you can switch between branches on your terminal when you like first do the git pull or like whenever you update your local repository. If you do git branch -a, you'll see all the branches. And the ultimate, most often when you create a branch, you're usually going to work on some code that is meant to be merged or like used in the main product. And once it's ready to be used in the main product, you have to initiate something called a pull request. And usually pull requests work differently based on the organization you're in. For example, like a lot of companies will have automated software that guides you through pull requests. Like I know, for example, like when I worked at Lyft, they had a very, very specific way you have to push like code and like open a pull request, and you have to put some specific like comments and stuff into the like info section. So to make sure that their like software understands what I'm doing. But basically the point is pull requests allow you to merge two branches with that like in a safe manner, and like you can give it like a commit message, and like you can and like usually you do this on the browser. I don't know, Ian, if you've done pull requests from locally. I don't know if that's even possible, but I usually do it in the browser.
Okay, no. It's
Right?
much more useful to just do it on browser.
Yeah. So once you push, like creating a pull request and working through it is like it's not too hard. They give you the instructions. You just have to make sure that your code is up to date with the remote code, and that can cause so many issues. I guarantee you at some point, if you use Git, you will have some issues with merge request or like merging branches and pull requests and merge conflicts. So just which is just basically like your code being out of date with compared to like the remote repository. So definitely feel free, like Ian said, Google is your best friend. Like no one remembers all the commands and everything that you need, so definitely feel free to like Google your issues and whatever error message Git throws at you. But yeah, branches are super useful. Use them in your projects, and pull requests are the way to merge your final code after you've finished working on a branch.
Yeah, so I can show a little demo of using branches. Where is my turn? So there are commands such as git branch and then the -a, which will show all the local and remote branches that you have currently on your local machine. And if you do git checkout /b, that is like the keyword, I guess the parameter to show that you're creating a new branch, and then your branch name. And it's going to automatically switch you into that new branch. And at this time, the branch and the master branches have the exact same version and the exact same version of the code. But then if you do, since you're in the new branch, if you go to file and you make a few changes, and now I made a few changes to the branch, and then now I'm going to add it and then commit to this branch. If you get status, you can tell you're on the my branch branch. And then if you do git push and then origin, and you do the branch name.
Yeah, make sure the first time you do it, you put the actual branch name. Don't put like master or anything, or you're gonna like merge the code into some place you don't want it to.
Right. And then if you go on the GitHub website, you can see that there is a master branch with the example text, hi, hello. And then if you go to the branch, you can see that there is a different version of the branch, different version of the code, excuse me. And it has the stuff that we already added previously.
And you can see that even on the website and in the terminal, there's a button for you to open the pull request. And that's how like you're gonna merge the two if you wanted to.
Right. And it's so much easier than doing it on terminal.
Oh, yeah.
So yeah, just to make sure, Git pushing and pulling with multiple branches, I want to emphasize that you should specify the branch name, or else it's going to automatically push it to the master branch, which can get really bad. And if you're working at a company, or if you're doing anything for an organization or a project, with multiple people, pushing to the main branch without any supervision is really, really bad. And so you specify the branch name.
Yeah, so yeah, I can take this. And also the question. So the really, really good part about GitHub is that the whole point of it is that you can reverse mistakes easily. That's why like version control is super important. It's to like make sure that you can reverse mistakes. Because the whole thing with GitHub is that you can always, like, every commit you make, you can always revert your code back to one of those commits at any point. And you can view the entire history of all the commits you've made. You could reset your code to like you can reset your code to any point, like any commit that you've made previously. So if you do make a mistake, yes, it's almost usually very easy to reverse, but it's just like more like it can be very annoying and hard to figure out how to reverse your code and like how to fix the mistake. So but yes, GitHub has a lot of fail safes for that kind of stuff. Kind of the whole point really of using GitHub. So it's like super useful to prevent mistakes, but they can be annoying to fix when they happen, which is why like caution is best when you first approach like pushing and pulling and stuff. Yeah. So good practices for collaboration. Yes. So these are all things, just about as what we were talking about, in order to avoid, mistakes and large like errors and a lot of annoying stuff going on for your repository. Make sure you do these things when you're working with a GitHub repository that has other people on it. First, you only want to merge your branch when you've gotten your code approved by others. So when you open a pull request, and you want to like make this change, don't immediately like merge your own branch unless like you have the authorization for it, you're like leading, or like maybe you don't need to verify with anyone on your team. But more often than not, it's very useful to get some second eyes and like another pair of eyes on your code, so you can add collaborators to review your code on GitHub. It's super useful, and it alerts them to take a look at your code, and you can review it, leave comments, approve it, reject it, etc. There's a lot of options that GitHub gives you in their native software itself. So like definitely take advantage of that, because bad code being merged from another branch is a number one cause of like your master code not working after. So you definitely want to make sure that everything is good. Committing often. This is something that I don't think a lot of people do, but it's super like useful. You don't want to commit large portions of code, because if something goes wrong, you're not going to know like exactly you will eventually figure it out, but like it can be harder to figure out what's going wrong. And committing often allows you to easily revert your code and make your code an older version. And yeah, so as long as you keep multiple versions of your code, something goes wrong, you can revert it. And committing often allows you to do that, and allows you to commit small chunks of code, so you don't have to like erase too much work if something goes wrong. Yeah, in general, that working on small amounts of code in general is better, because it allows you to diagnose the problem quicker. Similarly, you want to commit often so that GitHub is always up to date, and like you can revert code easily if you need. And merging often, yes. And similarly, you don't want to like look at like files and files of code and figure out like any conflicts that are happening, etc. So keep the commits small, and push and pull often. And yeah, in general, like ask other people if you have a question about the repository and you don't own it. Usually the README will have a lot of instructions. If it doesn't, reach out to anyone that you see in pushing code. Yeah, that should be it.
So I can show a demo of a pull request, and I'm on the current branch, my branch, and let's say I know that this stuff works, and I want to merge it into the main branch, which is, I guess, called master. And if you see here, the base master is what it's going to be added to, and you're comparing it to the current branch, which is my branch. And it says here, able to merge, which is a really, really good sign, which means that GitHub can do all the merging by itself, and it doesn't need any other manual input. But there's going to be times where it says there's conflicts at which manually go through every single, if it asks you to go through manually every single, I guess, merge conflict where there's different versions of the code and choose which version you want to keep in this new merged branch. So suppose there's like a variable with a equals 3 and then a equals 4. You have to choose if you want the 3 or the 4. And if you haven't merged in a while and you have a very large code base and you've done a lot of editing, this can get really, really, really tedious, and this can lead to your code breaking really easily because maybe you meant to choose this version of the code, but instead you accidentally click the other version of the code. So now you think it's supposed to be the new version, but you don't really know because obviously there's a lot of code to keep track of. And you can talk about what kind of leave a description of the. You can talk about the description of what the pull request is doing. So adds some lines to text. Then you create the pull request, and on the right here, you can see that you can add reviewers, which is pretty much adding who's going to review the code and give it the okay. So if you have any other person on this repository, it will show up. And if you click it, they'll notify you and ask them to review the code. And if they give you the AOK, or they give you a few suggestions of what to change. And once you get the AOK, you can create the pull request. And then you click, so once you get the OK, you no conflicts with because it has no conflicts with the base branch. So you click this, and then you can now successfully delete the my branch unless you want to do more stuff with it. Usually the way to do it is you create a branch for a certain functionality, and then after you're done creating the functionality, you delete it and then make a new branch based off the new master. And if you click example, you'll see that the master branch now has the changes made to the branch called my branch, where it has this stuff on there. And obviously my branch is still there, but if you want to add more changes to it, you're going to have to then make a pull request and then merge the two together.
Usually you should probably delete the branch after. There's no point of keeping it, and the code already exists in the main branch, so it should be fine. And also you don't have to merge it into main or master. You can merge it into any other branch too. So it doesn't have to be main. You saw that you can modify in the pull request. So you can combine any two branches with this. But usually it's always main if you're using it to develop features.
Yeah, and double emphasis on making sure that you get an approval before merging, because there's nothing worse than having someone just merge stuff into your branch without getting approval, because then all of a sudden you have this new version of the code that you weren't aware was going to be added into your version of the code. Or worse, in a company setting or in any other setting where you have someone pushing it into merging it into master without approval, and now the code is either broken or it works, but nobody knows what's going on apart from that one person. So there are some practices that you should really adhere to if you want to make your experience on GitHub smooth. And I think that's all for content that we have apart from this little Git game at the end. But before we do that, does anyone have any questions? I know we're ending a little early, but we can spend that time on Git game, I believe. And no question is a stupid question.
I thought you were saying it was stupid to have no questions. That doesn't make sense.
No question is a stupid question.
Yeah.
As in, I've asked a lot of stupid questions in my day.
But no question is a stupid question.
Oh, true. I've asked a lot of questions in my day.
A lot of questions that could be categorized as stupid.
Indeed. And you want to take this slide?
Yeah, I mean, so okay, this is like optional, honestly. So there's this thing called Git Game that helps you learn more about GitHub and how to like it's basically like a game that you play with terminal command or like Git commands. So you have to start by cloning it and like following the instructions in the README. You know, we can if you do want to do this, we'll be here to help you through it if you get stuck somewhere, and we can help you like with the commands. Um, I mean, if not, like you're also honestly free to go if you don't have any questions. Um, like the Git game is like it is super useful, and I recommend that you do it at some point, but doesn't necessarily have to be now, but it is something that you should take a look at. So there's a link in the slideshow. Let me drop it here. But yeah, also like questions at any point. If you have something else to go to, you know, anything is fine. Feel free to drop the questions in the chat or unmute and ask.
Yeah, apart from that, thanks for coming. We really hope that you learned something about Git, even if you were a beginner. Even if you weren't a beginner, I hope you learned a few little useful commands or just reinforce your knowledge. And if you were a beginner, I hope this will encourage you to use GitHub. It's a really, really useful tool, and it's used pretty much in every setting in computer science, from your classes to personal projects to clubs and orgs to hackathon projects to companies. And yeah, wow.